Hello, my Form 5s. Okay, welcome back to our weekly class. Alright, let's get into it. Last week, we have learned about engines. Okay, if you still remember, the suck, squeeze, bang, blow, the 4 stages. Okay, very simple stuff. Okay, today we are going to learn even simpler stuff, which is calculation. Okay, some of you might not like this. Okay, but I swear it will be a very simple subchapter. Okay, alright, so let's look at the basic concept. I'm sure all of you know what is distance. Okay, from A to B is distance. Okay, from point A to point B is distance. Okay, so the length of movement, you don't need to memorize this. Okay, so there are two things, actually three, you need to learn today. Okay, one is speed and another is velocity. They are the same thing. Okay, if in the exam they ask for speed, they ask for velocity, basically they ask for the same thing. Okay, normally they will use velocity. Okay, because that's the proper word to use. Okay, they might ask for speed as well. Okay, doesn't matter. Okay, so what's the meaning of speed? Okay, distance travel per unit of time. Okay, means distance divided by time. Okay, distance divided by time. Okay, I'm sure you look at your car meter, you know how fast your car is going. Okay, normally on your car it says kilometer per hour. Okay, so can you see distance kilometer divided by time? Okay, this is the divide. So from this I'm sure you know. Okay, but from here we don't use kilometer and hour because as you remember from form 1, okay, I'm not sure you do, but km and h is not the SI unit. Remember what is SI unit, which is set by the international standard. So instead we use meter and second. Okay, what is the -1 here? Same meaning as the slash lah. So we use meter per second. Okay, ms instead of kmh. Will they ask you to convert? No. Okay, this is not your job. Okay, you just have to know ms. Okay, and then velocity is the same thing, but it has a bit of difference because it has direction. Okay, but basically they are the same. If they ask for velocity or speed, same thing. Unit the same, calculation also the same. Okay, and then after I got my speed and velocity, if I divide by time one more time, okay, can you see I'm divided by time here? If I divide it once more, okay, means I divide it 2 times, I get acceleration. Okay, acceleration. Okay, acceleration means, you know what's accelerate? When you step on the pedal of your car, the car goes faster, that is accelerate. Okay, velocity is when you constant speed. Let's say you drive 80 km per hour on the highway, you stay at 80. But when you accelerate means you make the car faster. Okay, so that's the rate of change of velocity, or you can say change in velocity per unit time. Okay, so means just now distance. Okay, I think it's written here. So distance divided by time, okay, is velocity. So velocity divide by time again, I get acceleration. Okay, so how do we calculate this? We take final minus initial. Okay, initial means starting lah. Okay, so there's a minus here, not like just now distance we should already divide. So there's a minus here, and then divide by time, you get acceleration. Okay, so the unit is s minus 2. Just now it's -1 because I divide by time 1 time. Now I divide by time 2 times, so it's ms minus 2. Okay, simple. Or you can say m/s2. Same thing. Just now it's m/s because divide by time. Okay, this is distance. Okay, I write this out, you should be able to understand. This is velocity, this is acceleration. So can you see? Divide by time 1 time, divide by time another time. So the unit pretty much explains to you. Alright, so that's all easy to understand, but how do we use it? How do we calculate this? Okay, let's look at question 1. Okay, so the diagram shows 3 points A, B, and C separated by 3, 4, 5. When a student moves from A to B, okay, and then to C, the displacement traveled is, okay, so what is displacement? Okay, it's not mentioned in the notes here. Okay, so distance is the same as displacement. But what are the difference here? Okay, let's say now I were to travel like this. Okay, from A to B. This is distance. Okay, the curvy road is distance. But the straight distance, we call it displacement. okay, the straight distance. Okay, sometimes we look at the straight distance. That's why you have speed and velocity, because distance becomes speed, okay, displacements become velocity, okay, if you must know, okay, but they won't ask that deep into your exam, okay, this is mostly physics stuff lah, okay, but that doesn't hurt to know, okay, if your teacher gives you a trick question, then you know. Okay, so 3, 4, if you write 7, that is wrong, because 7 is distance. Okay, so what is the displacement? Straight distance from A to C, which is 5. Okay, so this is more of an understanding question, okay, not calculation. So number 2, if the time travel is 10 seconds, the speed is, look at here, speed. So speed, I don't use displacement, I use distance. So what's the distance here? Distance was 7 divided by how many, what's the time? 10, because 10 seconds. Okay, remember the formula, distance divided by time. So 7 divided by 10, you should get 0.7. Alright, pretty easy to understand. Number 3, the velocity will be, now they don't want speed, they want velocity. Okay, velocity, they don't use distance, velocity, you need to use displacement. Okay, so what's the displacement? It is 5. Okay, and then what's the time again? 10. Okay, time doesn't change, so you get 0.5. So can you see the difference between distance and displacement? Okay, speed and velocity. Okay, so good to know. All right, number 4, velocity increase from 10 to 30 in 5 seconds. What's the acceleration? So what's the formula of acceleration? Acceleration is final velocity minus initial velocity. Okay, it's up there. Okay, divided by time. So what's my final? Okay, 10 to 30. This is my initial. 10 is starting. 30 is final. So 30 minus 10 divided by 5. So 20 divided by 5, you should get 4. Okay, look at the unit, ms minus 2 instead of 1, because acceleration is divided by 2 times. Alright, simple. Okay, next. Number 5, a ball starts moving from rest with a uniform acceleration of 2. So now they give you acceleration. Okay, what is the velocity of the ball 2 minutes later? So we first convert the 2 minutes. We cannot use 2 minutes, we need to use seconds. So 2 minutes, how many seconds? 2 minutes is 120 seconds. Okay, so just now we know acceleration is final velocity minus initial velocity, okay, over time. So what's my acceleration? Instead of calculating acceleration, they gave you the acceleration. So the A is 2. What's the time? Okay, we sub it in. Time is 120. Okay, here's the question. They want you to find what's the velocity 2 minutes later. Later means that's the final. So my final is what I don't know. But they didn't give initial. Okay, sometimes they don't give you a number. Start moving from rest. What does it mean? Rest means 0. The starting is 0. So initial is 0. Okay, or you can don't write it at all lah. Okay, so sometimes don't think that they don't give you, it's hidden in the words. Okay, so 120 times 2, you get 240 equals to final. Okay, don't need to write the minus 0 lah. Okay, so what's the answer? The answer should be 240. Alright, simple. Okay, let's look at question 6. An object moves with a velocity of 25. Okay, starts decelerating. Okay, what is decelerating? Okay, when you see decelerating, okay, it means negative acceleration. Okay, accelerate means I make my car faster. When I decelerate means I make my car slower, which means negative acceleration. So you should put a negative in front of the A. Okay, so starts decelerating, so they start here. Okay, so this is the initial. Okay, good to label. This is a very good, when you do MS or maths, make sure you label them, easy for you to understand. Okay, starts decelerating uniformly at 5. Okay, so can you write 5? No, you should write negative 5. Okay, so because this is deceleration, after what time will object come to rest? So rest is final. Okay, so what's rest again? Rest is 0. So let's look at our formula. Acceleration equals to final minus initial, okay, divide by time. So what do they want now? They want time. Okay, they want time. Okay, so what's my acceleration? My acceleration is -5. My final is 0. My initial is, what's my initial again? Initial is 25. Okay, so you get -5 equals to 0 minus 25 is -25 over time. Okay, so you get time equals to -25 divided by -5. Cut, you get 5 seconds. Okay, what happens if you forgot to put the negative? Because deceleration, you think, never mind, I'll just put positive. Okay, in this case, you might get away with it, but you will get a very strange answer. Your time will be negative. Okay, this is no negative here. So, -25 over 5. You should get -5, which is weird because you can't get negative time. Doesn't make sense. Do you have negative time? Okay, oh, I run this track in -5 seconds. What do? You reverse. Okay, doesn't make sense. Okay, so you might get away with it. You might see -5, the nearest answer 5 lor. So you just write 5 lah. Maybe you can get away with it. Okay, but the problem is, please don't do this. Okay, you might get wrong in the exam, especially in paper 2. So make sure you understand decelerating is negative acceleration. Alright, this is more of a physics stuff, but good to know. Alright, you might not know how your teacher tricks you. Alright, question 7. If a car accelerates from 5 to 15, so very simple here, this is initial, this is final, in 2 seconds, what's the average acceleration? Okay, wow, what is average acceleration? You don't need to know the average, just calculate the acceleration. So A equals to 15 minus 5 over 2. Okay, so 10 over 2, you get 5. Okay, don't forget your unit, that's ms minus 2, because acceleration divided by 2 times. Alright, simple. Okay, number 8. How long does it take to accelerate an object from rest to 10? Okay, again, rest is 0. Okay, if the acceleration is 2, now they don't give you the acceleration, they don't give you the time, they want you to count the time. So again, acceleration is 2. Okay, I should be sub in lah, make it fast. Okay, 0 to 10, so 10 minus 0 over time. Okay, so 2 equals to 10 divided by time, so your time is 5 seconds. Okay, please don't ignore the unit, you might lose marks there. Alright, okay, very simple. Let's go to the next subchapter. The video is we still have a bit of time. Okay, I don't want to split this into 2. Okay, easier for you. All right, how do we measure velocity? Okay, there are 2 ways of measuring velocity. Number 1, you use a high-speed camera. Okay, you know it's a high-speed camera. So the camera that can be slowed down. Okay. Normally our phones can do it now. Okay, Samsung has this super slow-mo thing. Okay, if your parents have sped in highways before, they will know. Okay, they are kena saman of speeding. Okay, this is the thing that capture them. Okay, can you overrun this? Unless you fly like what, 500 km/h, I don't think any car can do that. Okay, so they will catch you with any speed you are speeding at. Okay, so that's a high-speed camera. All right, so in our school setting, we don't have this canggih stuff. We use the primitive stuff, the lousy stuff. Okay, the Sakai stuff. Okay, we use something called ticker timer. Okay, this is how you measure. Oh, sorry, it's already mentioned here. Okay, use this to measure time, distance. Okay, the main thing is speed. Okay, you can use this to measure speed. Okay, it's a very, very good thing to use. Okay, how does it work? A ticker timer looks like this. Okay, so basically this machine, can you see this paper? Okay, this paper is what we call a ticker tape. Okay, so we read the ticker tape. This is like a, what do you call it? The earthquake machine. Okay, so earthquake machine will mark on the paper how strong the earthquake is. We read the paper. So same thing here. All right, so how do you do this? Okay, let you look at the experiment. This is the experiment. So imagine you have a trolley, and then you tie the ticker tape to the ticker timer, and then when this trolley slides down, so this ticker timer will make dots on the paper, sort of like this. Okay, so imagine this is the paper, this is the ticker tape. When I pull the ticker tape, I will dot on it. Okay, I will dot on it. So by reading the dots, I know how fast the car is moving. If the dot is very far away, means the car is moving very fast. If the dot is very close apart, can you see my tape is moving very slow? So means the car is going very slow. Okay, so by reading the tape, we know how the car is going. Okay, we can't use this in real life in our cars because you hang a tape around your car. No. Okay, so this is the best way we use to study velocity. All right, so this is what we call a ticker timer. Okay, ticker tape. All right, so there's a setting I need you to memorize here. Okay, the ticker tape makes the ticker timer, sorry, makes 50 ticks in a second. Okay, means 1 second it dots 50 times. Okay, so 50 ticks in a second, 50 dots in a second. Okay, so therefore to make one tick, okay, this is basic maths. So to make one tick, 1 divided by 50, so one tick is 0.02 seconds. So by counting how many ticks, you know how much time has gone by. So let's say, okay, here's the thing, you don't count the first tick. Okay, please write here, don't count the first one. Okay, don't count the first. Why? Like when you go for tuition, your tuition is from 3 to 6. Do you count 3? No, you count from 4. 4, 5, 6. So that is 3 hours. Okay, same concept here. This is to count time. So we don't count the first one. So how many tick is here? Can you see? 1, 2, 3, 4, 5. One tick is 0.02 second. 5 ticks, I know this is 0.1 second. Okay, and then I measure this tape. I know this is 6 cm. Okay, I know this is 6 cm. So from I know the distance, I know the time. So I can calculate my velocity. Okay, so what's the velocity? So you can count here. 6, please remember to change to 0.06 meter because I may need to use SI unit. So 0.06 divided by 0.1, you should get 0.6 meter per second. So this is how fast this car is going. So can you see from ticker tape, you don't need a high-speed camera. Okay, from this ticker tape, of course it's good to have a high-speed camera because you can rewind it back, it's more accurate. Okay, but this thing, it's the old stuff. Okay, this is how we use. Okay, so let's look at our tape. We have 4 examples here. So like I said just now, if your tick is very close together, okay, I'm moving very slow. Okay, low velocity. If they are very far apart, high velocity. Okay, these 2 cases I want you to remember. Okay, can you see the dot is getting closer? Not. Okay, they reverse the direction of movement. Means the tape is pulling that way. So you should see from here. So can you see if the tape is pulling that way, it's pulling this way. So means I start from here. Okay, I start from it because the tape is pulling this way. So I start from here. Can you see the dots are getting further and further apart, which means this trolley is accelerating. Okay, I'm accelerating. Can you see it's the speed increases? Okay, as for this, the speed is slowing down. Okay, so velocity decrease or deceleration. Please look at the arrow. Okay, please look at the arrow. Okay, see where they pull the tape. Okay, if they pull it, like in this case, they pull it to the right, so you start from the right. Okay, I hope this makes sense. Okay, because it's very hard for me to show it here. Okay, I can show it better in our physical class. No worries, I'll do this again in physical class. Okay, I'm sure we have a lot of time. Okay, SPM is gonna get delayed most likely. All right, so this is, I think I'll stop here. Okay, this will be all because any more calculations, I think your head is gonna burst. All right, so I'll talk about the acceleration. The calculation of ticker tape next video. All right, nothing much. Okay, so let's look at the exercise. Can you see the arrow is pulling that way again? Okay, supposedly it's to pull that way. Most books pull that way. I don't know why is the note pulling that way. I don't know. So you start looking at here. Okay, so you start looking at here. So this is high velocity. Okay, high velocity, or you can say constant. Okay, it is high velocity but it's constant, means the speed is maintaining. Can you see the dots are equally spaced? But here, this is low velocity, also constant. Okay, my velocity is not changing, just going a bit slow. But here, looking at here, can you see the dots getting further and further and further? This is acceleration. Okay, so here, this is getting slower, This is deceleration. All right, that's all. Very simple. Okay, so this is so simple. Length of ticker tape. Okay, oh, this should be in your notes. You should measure it. Okay, I cannot measure it. Okay, because the scale is different. Okay, I'll talk about this next week. All right. So nothing much here. Okay, very simple calculation today. Okay, I hope you learned something. Okay, for guys lah, especially, this should be a very, this is not really calculation. This is more of an understanding stuff. All right, so that's it from me for this week's video. I hope you understand. If you don't, feel free to ask me any question. Feel free to watch these videos a few more times. Okay, basically this is a very simple concept. Doesn't mean it's not important. Simple but very important. Okay, please don't ignore this. Please don't think, oh, this is very simple so I can get mistakes and all. No. Okay, very easy part to score in this chapter. All right, so I'll see you again next week. Okay, the MCU is very extended, so we won't be seeing each other for, I think, at least 5 more weeks lah. All right, so stay safe, do your homework, watch my videos, and keep learning. I'll see you again next week. All right, bye bye.